And what number are we looking at?
I don't care really. One of
Mine is
those.
29 because it fits perfectly right here.
Okay.
Looks good.
My circle looks really bad.
Looks good. Alright, so if you look at number 29 up here that Erin has.
Alright. So we're gonna move the 1 to the other side and do like completing the square. And when you do that, you have x squared plus 4x and then y squared plus 4y. So either way it's a 4. So 4 divided by 2 squared is 2 squared. That's 4. When you factor that, it is y plus 2 and x plus 2 squared. You want to add the 4's from the 4 to the other side. To get 9, you want to square root the 9 for your radius, and then your center is the opposite of what's in the parentheses. So it's -2 and -2. Yeah. Thank you.
Any questions for 29?
It's beautiful, isn't it? It's really bad.
No, it's fine. I see.
It still
It doesn't look like an egg.
It's not really a circle though. It kind of has a pointed side.
It's better than
It's almost your face.
Eris. I feel like I have to be a mom. Go to your room. Don't talk to your sister like that.
Sister.
Brother. Sorry. I always say sister. I'm sorry. It's just. Michael, Michael is going to number 35.
I heard it's pretty hot. In my room? Oh, it's cool. See, I can like it's 90 degrees.
Michael, you got it?
See, Chelsea,
Yeah,
that was
my
mine.
Pretty much.
Yeah, I did.
All right, ladies and gentlemen, Brandon, come on.
So this is the equation they gave me. So find the x-intercept, you plug in 0 for y, and then you take 3 squared is 9, subtract the 3, and you have x minus 2 equals 0. Or, well, first hit the square to 0, and then add the 2 over. So then x equals 2, but it's 2, 0 is the x-intercept, but it's a double root because it's the plus or minus 0. And then for the y-intercept, I plugged in 0 for x. So -2 squared is 4, and I subtracted the 4 over to make it 5, and then y plus 3 squared equals 5. Squared them both, subtracted the 3, and I got the -3 plus or minus the square root of 5. The y-intercepts.
Any questions for Michael? If you have to, make sure that you simplify the radical. His square root of 5 didn't need simplified, but make sure you do simplify it if that would be the case. I think the last one had the square root of 28. So make sure you simplify this. Good job. You can, yeah, you can just place it in the block there. Numbers here, so I'm gonna skew there a little bit. Same thing with this one.
You don't even know?
Nope.
Okay.
What's that mean? Yup.
So when you take 4 times 9 squares, you get 9. I think that's maybe a negative 49. I think that's what it is. That's okay.
Yeah.
Just squeeze it on the page.
No, that one.
Look, man. Look at this. Just saying. All right, so questions with circles. Finding the center, finding the radius, completing the square. No. But the parabolas are just as nice. You only have to complete the square for one variable instead of 2. That's something. Yeah? So we're going to talk about the parabola today. It's going to be the more geometrical definition from the algebraic definition that we would have done in chapter 4 of algebra 2, and we also did them this year in chapter 2, chapter 2, section 1. They're gonna meet certain geometric properties. So we'll still be doing algebra behind that because we have to complete the square to get them in a specific form. But there are special properties that a parabola has in geometry, analytical geometry, compared to the properties it would have in regular algebra. So yes, there's an axis of symmetry, but we're not using negative b divided by 2a to find it. We actually won't really find the axis of symmetry. It's gonna be there, but we're not gonna like identify it. There's other parts of the parabola that will be identifying. Today we're gonna do like the intro to the parabola. We have to pretty much like look at all the pieces that are involved in the parabola, how to find them, what the formula looks like, if it's vertical versus horizontal. And then we'll work through 2 problems where we try and find all the information and graph it. Tomorrow we'll do 1 remaining problem, and it'll be kind of like the opposite of what we do today. So we'll have a graph or a picture, and from that picture we'll try and work backwards and create the equation. And then Thursday and Friday are going to work the same way, but we'll move to the ellipse. So the first day of the section is going to be pretty involved. There's going to be a lot of notes and information to kind of absorb. And then the second day, it should be a little more laid back. So in my mind, tomorrow you should have some time at the end of class to start your homework. Friday you should have time at the end of class to start your homework. Kind of like every other day, there should be some time in class. And if you have a book, Libby, you already have, oh, Nick always has his book in here. Does anybody always bring their book? A couple of you do. I've asked a couple of kids to like bring their book, and maybe we'll keep it in the back of the classroom so that we have a couple of books to use instead of just taking a picture from the 1 or 2 copies that I have, just to get that part going quicker so you can start your homework. So, talking about the parabola today. Yesterday we said all these definitions start off with a locus, which is a collection of points. And then those points have to meet a special property. So yesterday, the property that the points had to meet was that each point was the same distance from the center. So we're going to start out the definition the same way. A collection of points just to remind you, those points are x, y. Where each point, so each individual point, is equidistant from a fixed line, so no longer the center, but a fixed line, which is called the directrix. So that's a new word that we'll be talking about. So this special line, a directrix. And a fixed point that is not on the line. And that's called the focus. So we have these 2 parts that are creating our parabola. Any point on the parabola should travel the same distance to the focus and the directrix. A different point on the parabola is going to travel a distance to get to the focus, but it's going to get the same distance to go to the directrix. So each individual point is going to travel a specific distance to go to these 2 things. That distance it travels is the same when it travels to the directrix or when it travels to the focus, if a point could truly travel. It can't really travel, but if it could. So we're going to look at the vertical option and the horizontal option. And as we do each conic, I'm going to try and keep them like vertical on the left, the horizontal on the right. We'll look at the graph and the parts of the graph and how that kind of creates the graph, and then we'll go through the actual equation. So that whole page there, we'll kind of just divide down the middle, vertical on the left, the horizontal on the right. We're not going to worry about the slant right now because I want you to kind of just focus on the regular graphs. We don't need to like try and tilt them already. So vertical versus horizontal. So we're going to look at the graph and then try and see how the equation matches, or like the pieces of the graph are created from the equation. So vertical graph is the graph that we know have graphed multiple times. Like draw yourself a That parabola still has a vertex, so that's not going to change. The vertex is still the maximum or minimum point. And yes, there is still a line of symmetry, but we won't really be graphing the line of symmetry, but I just want you to kind of think about it right now. Because on the same line that the vertex would be located on, there is this point that's called the focus. And literally, the parabola is kind of like focusing on that point. It's like its focal point. That point can be anywhere in the mouth of the parabola. So it could be close to the vertex. It could be really far away from the vertex. That's going to help determine if it's a wide parabola or a narrow parabola. So wherever that location is. But once you get that point, it's called fixed because it's fixed within that graph. So the point doesn't like wiggle around in the graph. Once you find the point, it's just that one point for that graph. The other part of the definition says that there is a directrix. The directrix is kind of like a boundary line that's going to be underneath. It's the same distance to get from the vertex to the focus as it would be to get to the vertex to the directrix. That is by the definition of a parabola using the analytical geometry definition. So any point on my graph, I should travel the same distance to go to the focus, the same distance to go to the vertex. So that's what the definition is saying. Now specifically, this distance here from the vertex to the focus is called P, and from the vertex to the directrix, that is also called P. So that gets a special value because I'm going to use that distance of P to find the focus and to find the directrix. So let's list this here as this line is our directrix. So what the definition says is that you can pick any point on this curve. It doesn't matter where your point is. So maybe I'll choose it to be over here. And the distance from the focus to that point, or that point down to the directrix, it says should be the same. And it looks like mine is pretty close to being the same. So it's just that distance, the space from the point on the graph to the focus, the space from the point on the graph to the directrix, that should be the same. That's how the parabola is created. So any point on that graph would travel the same space to get from one part of the focus to the directrix. It'll always connect down perpendicular to get there. So that's by the definition of a parabola. Questions? So we have a vertex, which every graph already had. Now we have this focus and the directrix that's creating the curve of the parabola. So we're going to draw the same graph, but we're going to make it go horizontal, which is usually not how we graph because it's no longer a function. But we're not really worried about functions anymore because we've done every function we could possibly look at, even all the trig functions. So we've done lots of functions. Every single function that exists, I think we've done. So here's my horizontal graph. Like, make yourself a U that goes sideways. Mine looks pretty smooth. That looks like a really good one. Again, you've got a vertex still in the middle of the graph, but you no longer can say it's the highest or lowest point. No longer is a max or min, it kind of goes left or right. Directly in line with the vertex is somewhere a focus. Again, it could be closer to the parabola, it could be further away or from the vertex. It just depends on the numerical values that are in the equation. And you'll kind of see after your graph a couple of patterns as to why it would be closer or further away. And then this distance is going to be P. That number is in the equation that we'll use. Just like negative b divided by 2a. Like those numbers are in the equation. The distance of p will be in the equation that we use. And then on the other side, we have that directrix. And the distance from the vertex to the directrix is also p. Because any point on the graph should be pretty much in the middle of those two values. The vertex is the actual midpoint of the focus and directrix. Ooh. So every time you graph a vertex, take a look at it. After you graph the focus and the directrix, it should be in the middle of the two of them. If it isn't, then you calculated something wrong. Questions? So we're going to see if we can look at the equations and how those equations affect the graph. So just like we had an equation ax squared plus bx plus c, or x minus h squared plus k equals y. So like we've got these equations for parabolas. So we're also going to have an equation when it's in standard form for the parabola. And I'm keeping the vertical on the left so that right above you have the vertical graph, the horizontal on the right. So Brandon, all of the graphs that we've done for parabolas have been vertical. What term is squared if you have a vertical parabola? X. So when we write our standard equation, we are going to have that x minus h squared, which is the typical form that we've had for parabolas. However, it's not going to be equal to y. Instead, it's going to be equal to 4p times y minus k. The p here is how we get the distance. How far is the focus from the vertex? How far is the directrix from the vertex? The number 4 was derived by a person, unfortunately probably a male, who found a pattern and recognized that if a 4 is there and I have a square term on the left and a number on the right, it's always going to create this parabolic shape. Just like the quadratic formula is always divided by 2 times a. Again, they found a pattern that it works with a 2 there, and it works every time to find a solution for a quadratic because of the 2. So those numbers were derived by somebody just kind of literally taking x's and y's, plugging them in, seeing what happens with different formulas, patterns that they find. I wish I could be that smart.
You just have to be that determined.
Or determined. I'm not sure if I'm that determined anymore either. I used to be really determined. But you lose steam after a while. Or you become a mom and then you lose energy because you're more determined to make sure they're doing well. That's how I'm just determined for my kids. For you as well. See, once a mom, always a mom, I guess. I must have been a really bad teacher if I wasn't a mom. I feel like I'm so much better. All right. So, looking at the vertical, Chelsea, do you think you could try and come up with a horizontal equation?
Is it the square root of x minus h?
What term do you think would be squared if it was?
Probably y.
Probably y. Yeah, probably y. I mean, you're making it way too hard. So the horizontal is kind of going to be the flip of the vertical. The y is going to be squared. The square term we're going to try and keep on the left side just to be consistent. And then on the right, we still have 4p, but now it's x minus h. See, that is what I was going to say. So h is always with x because h moves your graph left or right. That's the x value that's shifting left or right. Every single graph that we've done always moves h left or right. K is always with y because that's the part that moves your graph vertically up or down, no matter what. So even though it's on the right side, x and h still go together. Other questions? So just graphing, I know you got a lot of space, you don't need all that space, but just kind of graphing the two different options. So we could have a graph that goes up and a graph that goes down. The part that makes the graph go up is now the p-value. So in our old form of parabolas, it was always a. If a is positive, it goes up. If a is negative, it goes down. So now we're going to be looking at the p, because there's not an a in these. So the p-value creates our graph going up or down. And when it's horizontal, what do you think would have to happen with P for it to go to the right? Right? Yeah, so when P is greater than 0, it moves to the right. That's the direction the positive numbers move. They move bigger, bigger, bigger to the right. And when it's less than 0, then it opens left. Red. And you don't have a parabola. You have a degenerate conic, which we'll talk about, but not quite yet. Kate didn't like that word. She's like, let's not do that yet. Other questions? Alright, so we're going to look at the first example on the top of the next page. Unfortunately, you might have to do a little flipping back and forth. The first example is already in standard form. So I'm giving you a free one here. We don't have to do any algebraic work. The goal is just to kind of get used to taking the pieces, finding the correct parts, how can we graph. So find the focus, directrix, vertex, which really you need the vertex first to get the focus and the directrix, of the equation y minus 3 quantity squared equals x, or 8 times x minus 2 quantity, the quantity of x minus 2. Then it says sketch the graph. So without doing any work, just looking at the equation, is it vertical or horizontal? Sabrina? Horizontal. Okay, so she said horizontal because?
Because the y side is the one that's squared.
Yeah, the y side is the one that's squared. And would it go left or right? Do you know?
We go right because it's greater than 4.
Yeah. So that number there, if it's positive, it's going to go to the right. If it's negative, it's going to go to the left. Now that number that I circled is equal to 4p. So the 4 is already calculated in that value. That's the form, or the equation has that 4, that constant value in it. So that means p is actually 2. And we're going to need that p so we can find the focus and the directrix. Because p takes me the distance that I need to move to get to the focus, move to go down to the directrix if it was a vertical graph. So see if you can think about what the vertex is. And then you'll probably have to flip backwards to get the formula for the focus and the formula for the directrix. Chelsea, are you warm yet?
Not really. It's okay.
Oh, I'm roasting.
I'm always cold.
Didn't you used to have that big blanket sweater thing?
Uh-huh.
What happened to that? Yes, thank you. That's what it's called.
Oh no. It's too warm for a Sherpa. Not too warm.
Do you know what the vertex would be? You're close. Where's H and K, Ka? What's H always with? There you go. So that's the trick. H is always with X, K is always with Y. I know you're so used to seeing it written the other way, but 2, 3, that would be your vertex. All right, so we need to find the focus, knowing that this is horizontal. So that means my point for the focus is going to move left or right, right or left, making sure I'm moving in the right direction. So my H value is going to increase with P, because it's going to make it move to the right. The K part isn't changing, because it's going to be the same height of the vertex. So Brandon, what would that be?
It would be 4, 3.
Yeah, 4, 3, because H is 2, you're adding 2, 2 plus 2 makes 4. The directrix is a line. It's a vertical line, x equals form, and instead of adding p, we subtract, because we go the other way, it's behind the parabola. So that's going to make the directrix x equals 0. Questions? Right, so now I'm going to try and graph. See if we can at least plot this information, and then we'll try and create the rest of the parabola. I have graph paper that I'll pull out again for you. If you'd like to use graph paper for your homework, you'll be graphing 5 graphs. If you can handle graphing 5 graphs by hand, that's fine. If you prefer to use graph paper, that is fine as well. Totally up to you. So over 2, up 3, over 4, up 3. Those 2 points should line on that same horizontal line. That's really our like line of symmetry. And then the directrix is a vertical line at x equals 0. The parabola should never cross the directrix. It needs to open toward the focus. So here's the problem with what we have done so far. We don't know how wide the graph is. So it could be really narrow, or it could be a wide graph. And we have to figure that part out. No, you can't just guess. I mean, it's not very mathematical if you just draw a curve, although arrows probably wouldn't do that. But we're going to have to find out 2 other points. One way you could do it is pick any random x. Pick an x, that's your independent variable, plug it in, and you get out a y. The other way is still by choosing an x, but I'm going to use the focus point because anytime you use the focus, you'll always get a perfect square. And then you won't have to worry about taking the square root of like 24 or the square root of 40. It's going to be a nice number to take the square root of. So my focus is right here at 4. I'm going to get a point above and below it, somewhere above and below. So then I have those 3 points lining in a line, and I have 2 points lining up on the same horizontal line. It keeps it kind of equivalent and symmetrical. So go to the focus. My focus value is 4. That's going to be the x that I plug into the equation to get corresponding y values. You don't have to choose that. You can pick any x. The focus always works nicely, though. So we have y minus, what's it, 3 equals 8 times the x value from the focus is 4, and then it was minus 2. So wherever x is, I'm just plugging the x from the focus. And then I'm going to simplify. So Kate, if we take the square root of 16, you get
4.
what kind of 4? So how many y values do you now have? 2. What are those y values? Say again. It is. You said 4. I think I was thinking 2 y values, and I write it down. Yeah. So you get a 7 and a negative 1. So plotting those 2 other points, going to the focus and moving up 4 to get to 7, and down 4 to get to negative 1. So now I have 3 points lying on the same vertical line that gives me the width. I have those 2 points that are on that same horizontal line, which would be the vertex and the focus. Make sure you're connecting the right point. You want to connect it through the vertex, not the focus. The focus should be in the middle of the parabola still. Not really the middle, but inside of it. Questions? So we're going to see if we can do another one. The second one, of course, you're going to have to do a little bit of work for. So it's not in the standard form that this first one was in. Find the vertex and the focus. We actually need the directrix too, because it does say to sketch the graph. X squared minus 2x plus 4y minus 3 equals 0. So without doing work yet, like think about the direction the graph should go. So find the value that's squared. Libby, which one is squared? And if x is squared, what direction does this go?
It would be vertical.
Right, so this is vertical. Because we have an x squared. So just thinking about the vertical form, x is supposed to be on the left, y is supposed to be on the right. So that's the standard form for a vertical parabola. How would you get what we have in the standard form? Kate?
Move the 4 over.
Yeah, we gotta move the 4 over. So we have an x squared and a 2x. So she said move the 4 over, so it becomes negative 4y. What else do we have to do? Chelsea?
Move the 3 over.
Yeah, move the 3 over as well. So if it isn't an x, it needs to get to the other side. Because you have to complete the square for the squared term. Brandon, what number goes in there to complete the square?
It would be
positive 1. That number also goes on the other side. So on the left side, we completed the square by plugging in that positive 1, because negative 2 divided by 2 squared is 1. So now I have x minus 1 squared. On the right, we have a negative 4y plus 4. What do you think you'd have to do to the right to get it to be standard form? Kate? Yeah, pull out the 4. And it's a negative 4, so we're going to pull out the negative 4 with it. So that makes this then x minus, or y minus 1. Whatever coefficient is with y must come out. So once you pull that out, the stuff in parentheses should just be y by itself with a number. You can't have a 2 with the y. So if you have to pull out a number and you create a fraction by pulling that out, that's okay. So that number back here might be a fraction, but whatever coefficient is with y must be factored out. Any questions? So this is standard form right here. It looks exactly like my standard form. Find p, so 4p would be equal to negative 4. And then see if you can get the vertex, the focus, and the directrix. Again, you might need to flip it over to peek at the other side. This is now moving vertically, so our y point is changing. Brandon, what's the vertex? 1, 1. H and K are both 1. The focus, the H is staying the same because this graph is vertical, so H is still 1. For the y value, you're taking K plus P. So K is 1, P is negative 1. 1 plus negative 1 is 0. So my focus is going to be at 1, 0. And then the directrix is K, which is 1, plus, or minus P. So 1 minus negative 1 makes a 2. So the focus is going to be lower than the directrix because this graph goes down. Alright, we're going to make a little sketch here. Try and squeeze this in. Chelsea, did I leave you enough space?
You did.
Did I?
Yeah.
So point at 1, 1. The focus is at 1, 0. So that's down below. The directrix is at y equals 2, so that's just a horizontal line. So the last part's the tricky part. We want to get 2 other points. If you go to where your focus is, now I have a focus. I need to have a point on the left and the right of the focus because we're trying to figure out the width. So my focus, I need to get different x values. So that means we need to plug in y this time. So whatever the term is that isn't squared is what you're plugging in with the focus. So the focus y value is 0. So in my equation, I have x minus 1 squared, negative 4, and then 0 minus 1. So I'm using the focus, but I'm using the y this time because I need 2 x values to get the width. And the only way I can find out how wide it is to figure out how far left and right my graph goes. Kate, the square root of 4 would be? Plus or minus 2. So 1 point would be at 3, 0. So same y value. And the other point is at negative 1, 0. So now I know the width of the parabola. So I'm going over to 3 and over to negative 1. So the vertex was closer to the focus. My graph isn't as wide. Yes, so tomorrow you'll be given a picture, we'll come up with the equation.
Would the A value for this one be 2?
With the A value, there's no A value. So we'll never use that old parabola form. So we would work with this form, and then you could rearrange it to go back into the form. But we'll be using the standard form of a parabola with a conic definition. Other questions? So, graph paper, if you'd like to graph, the first 6 problems, 43 to 48, are not graphing, those are just matching. I just ask that you write some kind of work instead of just picking the letter A. And then there's 5 problems you're graphing by hand, and that's the bottom problems that are listed underneath there. So 5 graphs. 5 problems that you really have to have some work for. Algebraic work.